And thank you for joining our webinar for StableNet on VCCAP Beyond Just Monitoring here at InfoSim. My name is Stefan Rybeski, Director Solutions with InfoSim, and I will be moderating today's event. From our partner Dimension Data Germany, my dear friends Manfred and Müller and Senior Sales Specialist and Daniel Rösen, Solution Architect, will guide us through this webinar. Good afternoon to you, Manfred and Daniel, and a warm welcome to the webinar.
Yeah, hello, Stefan.
Hello, Stefan, Daniel here.
So before I hand over things to Manfred and Daniel, I have a couple of things I want you to know. First of all, you are muted when joining our audience in order to keep down the background noise. When you would like to ask a question, you have to raise your hand via the GoToWebinar application, and then you will be unmuted by us. Please be aware, this event is being recorded. During the webinar, we will upload a PDF of a slide deck for downloading. In addition, all of you will be notified tomorrow via email, including a link to the mentioned recording. That's all from my end so far. So I would like to go ahead and hand over control to Manfred and Daniel. Guys, are you ready to take over?
Yes, thank you, Stefan, for your introduction. My name is Manfred Müller, and I'm a sales specialist, now over 20 years at Dimension Data. I will give you some key information about Dimension Data and our focus. Then Daniel Rösen, our solution architect, will present and explain you a solution how we use StableNet for automation. At the end, I will summarize why it is valuable for you to cooperate with us. We believe we can make a difference. Every day, we enable our clients to do great things through the use and adaptation of technology. We believe in great things technology can do to accelerate the ambitions of our clients, our people, and the communities we work with every day. We, Dimension Data, are a global integrator and managed service provider. We believe we can make a difference. We help you to ensure you have the right digital infrastructure in place for your business so that you can harness the power of your data, turn it into information, and extract insights. This allows you to build more valuable relationships with your customers, embrace the new ways your people want to work, and navigate you through a landscape of ever-changing security threats. Now, I'd like to hand over to Daniel Rösen, our solution architect, to give you an example how we implemented StableNet on our own virtualized carrier core application platform at the eShelter Innovation Lab. He will show you how StableNet will manage dynamic resource allocation based on network traffic.
Hello, everybody. Thank you, Manfred, for handing over. My name is Daniel Rösen, Solution Architect at Dimension Data Service Provider Center of Excellence team. Focusing mainly on IP MPLS, IPv6, and recently virtualization for telecommunications and carriers. I want today tell you a little bit our VCCAP project and how we use StableNet in this context. To explain the motivation, I need to give you a little bit background. When looking at our customer base, which are mainly common telecommunications providers, service providers, broadcasters, we are seeing that they struggle with implementing new products for their customers, so adding revenue to their business. And one of the key points why this is the case is the use of purpose-built appliances. So they have dedicated hardware for services they offer to their customers. So these are special built hardware, sometimes having standard hardware inside, but you need to buy the hardware from the software, from the service vendors in order to deploy services. This takes a long time. Getting hardware deployed in your network, that might mean shipping and cabling, racking stuff up in dozens or hundreds of network locations in your network. A lot of organizational stuff. You need to integrate these devices in your own OSS systems. You do need to do all the documentation, process stuff. So from what we are seeing, it takes usually around roughly 12 to 18 months from start to ready for service. So in the end, it means a lot of time from product management, having an idea for service to offer to the clients, to actually generating revenue, go to market. So, but that's not the only problem. That's the initial problem, getting a new service deployed. But then you also have the problem with the limited lifetime of these dedicated appliances. So every couple of years, usually around 5 plus minus, you're having to replace this hardware because there are no spare parts available anymore. The vendor ceased support. They are going end of life. So you need to replace them with either newer models of the same vendor or switch to a completely different vendor, which also means usually changing designs, etc. So that means in the end, with having a lot of services, a lot of network sites, you're having a lot of network churn. So things are changing all day. There are customers of us who have basically changed Windows every night. And this is a lot of manual work involved, and as long as humans are involved, there's a lot of potential for mistakes. So you have outages, you have mistakes being made, which leads to customers complaining and customer experience going down. So, but these service providers are realizing that the classical IT departments and enterprises are adopting virtualization, and they are looking at that as a potential way out of this problem, because they see the agility to deploy new services as a key differentiator to differentiate against the competition. Who's first to market with a new service, with a new hype, with a new idea, is the first to gain market share and realize revenues. And they see virtualization and automation as a key to reduce the time to market and the general churn in the network and the service architectures in their data centers. NFV is seen as this concept. So we as a service provider, not as a service provider, as a system integrator, a lot of business is selling hardware. So this has an impact on us. In 2013, we realized this is most probably becoming the future development, that the revenue for us as a system integrator, the business for us will shift more and more from selling hardware to deploying, integrating, supporting, operating software. And thus we knew we had to build up knowledge and get our hands dirty, as I like to say, in virtualization technologies, and get an idea what works, what doesn't work, and build up competencies to stay relevant for our clients. They are going most probably in the not too distant future buying more and more hardware directly on the Chinese or the Taiwanese spot markets, commodity off the shelf server storage systems, etc. And their main struggle will be dealing with the software and automation. So we founded a project. We wanted to avoid the usual buzzword cloud. Because cloud, usually when people hear about cloud, they think about things like Amazon Web Services, Google Cloud, or whatever, these kind of public cloud offerings. which telco virtualization is not really. Some concepts get adopted, but it's not really what most people think about cloud. To avoid having misunderstandings, which we saw in the early days, we gave it a no name. We called it the Virtualized Carrier Core Application Platform, VCCAP or VCCAP, which then reflects our own experience in this NFV scene, network function virtualization scene. To explain a little bit the difference between classical virtualization and what NFV, network function virtualization, is all about, we have this diagram where on the bottom left side you see the hardware resources, the computing, storage, network hardware, the usual main ingredients of your data center, where you have the traditional non-virtualized approach. Operating systems directly installed on hardware with the applications on top. You might have some external storage systems, some fiber channel, some classical switching routing, but that's a traditional non-virtualized approach. Now you add a virtualization layer, things like VMware, vSphere, most popular in the enterprise market and even in some service providers, where you get simple server virtualization. You virtualize your compute hardware and start running multiple virtual machines on them, having better utilization, more flexibility. But that's still pretty much static in nature. If you get an umbrella management system like vCenter or comparable products, where you manage a whole data center infrastructure with your compute host, etc., under one umbrella and central system, then you're approaching what we call the data center virtualization or infrastructure as a service. This is usually where most virtualization efforts in the enterprise until quite recently have stopped, and in telecommunication service providers industry still stops. But this is not NFV. NFV has a bigger scope. On top of this virtualized infrastructure, you are having your services, so-called VNFs, virtualized network functions. So this might be services like a voice service, people calling each other. That might be a chat service. That might be some video service, broadcasting, video on demand, whatever you can think of in telecommunications and service provider networks, or even in enterprise networks, being different applications. For that, in NFV, you have dedicated VNF managers doing the life cycle management of these services. So starting up the services, implementing them automated, monitoring them for health, performance, reacting to changing workloads, scaling in, scaling out. So scaling your service so the customer experience remains in the green area. And that's when you have these kind of automation on the service level. We're talking about a partial NFV approach. In the end, if you have a lot of applications in your data center and you have multiple data centers which you take care of, and some services are delivered from many data centers in parallel to your customers, you need to have an instance having a complete picture of your whole infrastructure, all data center, all services. And for that, in NFV, you have the so-called NFV orchestrator. If you have that kind of automation level, which approaches nearly 100%, then we're talking about a full NFV approach. So this is our goal going onto this journey from the simple server virtualization, which we had to dig into in 2013. We were not the virtualization professionals. So we needed to get started from simple server virtualization, and nowadays are approaching the full NFV stage with all the kind of automation in place. So what did we do? We built a shared infrastructure platform, so put a lot of hardware together, talked with our partner vendors, built a design for that, basically data center network, compute hardware, storage hardware, etc., and built a setup which we deemed would be suitable for a service provider in design, with the main attributes of being scalable. So it's not just, let's say, a switch and 2 servers in the rack, which would be nice for some limited lab work, but it's not really an environment a service provider believes in and can say, okay, that is following carrier grade design principles. So also we added geo-redundancy, so our lab is distributed on 2 physical sites, only connected together with a standard IP/MPLS backbones without any technical shortcuts or tricks. So very comparable to a service provider network out there. And all this is built and designed according to the ETSI-NFV concepts and architectures. ETSI is the European Telecommunication Standards Body, which founded a working group about NFV in 2012 and began the work to standardize how all the components of NFV work together. So what do we use this platform for? VCCAP is mainly used as an NFV showcase to demonstrate what NFV is, how it could look like. Of course, there are always different shades of gray, so it's not set in stone how that has to look like, but depending on what the operator, the service provider, or even enterprises are having interest today into that kind of concepts, what their demands are, things are of course changing in detail. But we have a showcase demonstrating the concepts. And most important, we do knowledge building. So we are not just repeating PowerPoint from vendors, but we, as I say, we have our hands dirty. We actually implement stuff. We integrate multiple components of the NFV architecture from multiple vendors together and see what actually works today, aside from marketing, to be able to be a trusted advisor how to put things together. So we can also onboard applications on this platform. So if a vendor or a customer comes to us, tells us, okay, let's see, I have this application, I want to virtualize it. Can we automate stuff? How can this be done? So we can run proof of concept demos. We do testing and integration on this platform. And in case we are engaged in managed services operating such NFV platforms, we can do patch and change development and verification. And to give it a little bit more flesh, the next slide shows you roughly, not in all details, but roughly how this looks like at the moment in our eShelter facility in Frankfurt. It's a whole campus of data centers. We have the 2 sites. One site is located in the eShelter Innovation Lab, and the other one is 2 buildings away in the co-location area, where we have a couple of racks, of course, being the VCCAP compute network infrastructure racks, as well as testing equipment for Mixia, load generators, impairment devices, taps, network taps to support visibility in the old infrastructure, as well as dedicated equipment for the broadcast service provider industry. We have, for example, a satellite downlink for getting live video feeds and post-processing them and use them in POCs and lab work. So now coming to StableNet. As you can see, this is a lot of hardware. It's not just 1 switch, 2 servers. So, and that stuff is running 24/7 in a data center environment, but there may be outages over time. Things fail. It's the nature of hardware over the years, and we need to monitor in that dimensions. You can't do it manually anymore. You need to have systems to monitor that stuff. In the start, we used OpenNMS, free open source tool, but later on our demands increased, and we partnered with InfoSim to use their StableNet product to monitor the physical infrastructure, the hardware, the compute nodes, the storage systems, the whole network. And we integrated this infrastructure into StableNet for visibility. You can do drill downs on all ports. You get all kinds of statistics. Those of you who are already running StableNet certainly know all that stuff. It's not news to you. Those who don't know it, that's kind of stuff OSS monitoring systems usually provide you on a network view. But we are going farther than that. When you are looking at NFV with all the VNF managers and NFV orchestrators, this is really complicated stuff. That's not easy. The learning curve is quite steep. Getting started is not really easy. But you have options to get into this without implementing the whole NFV stack, the management and orchestration stack. And this is where StableNet shines in that point, because StableNet goes beyond just monitoring, beyond just observing performance or status, but you can also use StableNet to react on what he's seeing. And this is what we demonstrated recently also at the trade fair in Nice. A very simple demo setup where we implemented a demo service on our OpenStack platforms on VCCAP, where we have an Nginx front-end web server, which then, when customer requests, client requests are coming in, distributes the actual doing, the generation and delivery of content to backend servers. We have our XCR load generators, IX load generating HTTP requests, simulating web clients in large amounts. And we have StableNet monitoring the front-end and back-end systems, what the load situation is. So is the response time okay? Is the customer experience okay? And if not, we have to do something. And this is the reactive part StableNet can take. As you can see here, StableNet is detecting that certain thresholds get crossed. So let's say the response time gets higher than 10, 20 milliseconds, whatever, or CPU load on the backends gets too high. The amount of requests per second gets too high. StableNet can react on those kind of thresholds and then trigger a scale out. So it can go to OpenStack in our automation and start more backend servers to deal with the increasing traffic load. And when the traffic load from the customers or the simulated customers gets lower again, it can stop backend systems and tear them down, freeing up compute and storage resources for other services in the network. And that's something I think is very fancy, because it's not just a passive monitoring tool where your operation guys need to take a look at and react on alarms and then do some manual work to increase capacity, which might or might not be even possible at the very moment when it happens. But it can, with the right kind of automation connected to it, it can trigger adding capacity to the service on the fly when it happens, and also tear down excessive capacity to make room for other services which might have their peaks later on in the day. So that's what we wanted to show you on a dynamic orchestrated virtualized infrastructure. You can use StableNet as an entry point to get into automation. It's quite easy to implement. You don't need all the VNF managers and orchestrators and descriptors and whatever all is connected to that. You can start with StableNet already, getting into automation and reacting and making your environment, your data center environment, dynamically reacting to changing workloads. So thank you very much. I hope it was interesting for you. I would like to hand back to Manfred now.
Thank you, Daniel, for your clear explanation. I really liked it. So, and I hope you all could experience now an example how an automation solution with StableNet can help you to reach your targets. For your success, we bring experienced staff, have access to more than 35 service provider technology experts, as well as partnerships with technology leaders. Furthermore, we can ensure your end-to-end performance using test equipment, and we have an NFV reference in operation since 2013. If you would like to know more about it, you can contact us via the following email or ask questions right now in the following minutes.
Okay, great. Thanks very much, Manfred and Daniel, for this insights of our joint project here. So, as I can see in the meantime, there are a couple of questions. Let me pick up one. So I see this one from a customer. So is VCCAP a product ready to order through Dimension Data? Maybe Daniel, you can give an answer on it.
No, VCCAP is per se not a product. We do not really have the infrastructure to sell such a thing as a combined product, and it wouldn't actually react correctly to the market because every operator has different requirements. So our market proposition is that we help you to find the right combination of tools and build an infrastructure for yourself which fits your requirements. So no, we are not selling VCCAP as a product set in stone, but we can help you to build such an infrastructure.
Okay.
I hope that explains the question, answers the question properly.
Okay. So I have here one in addition. So it's a question from the partner side. So is it a closed ecosystem or can we join in as a partner? So maybe it's also you, Daniel, to give an answer.
It's not a closed ecosystem, absolutely not. It's actually changing quite often. It's what I didn't mention before, it's not a vertically integrated stack from one single hardware vendor. We have a whole zoo of like around 15 vendors taking part in VCCAP, hardware and software vendors, where we are exchanging stuff over time, upgrading stuff. So if someone is interested to join in, to also bring their customers to this platform to demonstrate things jointly with us and the others, we are happy to hear about it. So if you like to take part in such a NFV environment, we are happy to hear about you on our email address, which was just mentioned and will be in the recording and in the slides.
Okay, thanks for that. So regarding the time, the rest of the questions, I think we will give an answer on when offline so that everyone can get some more information of what we have talked about. So finally, I would like to thank everyone for joining us today. As I have mentioned earlier, a recording of this webinar will be made available to all of you tomorrow via email. We will keep the session open for a few more minutes in case anyone from our audience decides to type in another question. And so we will give them later offline an answer to. And yeah, let me say thank you, Manfred, Daniel, for this great session today. Any final remarks from your side?
Not special, just what we have already mentioned. If there is coming up any additional information requests or questions, you can contact and just drop us an email to the address we showed, or you can download on the slide set.
Okay, thanks.
Yeah, thank you as well for your attention and time, and have a nice day.
Okay, great. So our next global webinar day will be on October the 25th, so containing a live demo of our product StableNet. So in case you are not on our global webinar day invitation list, but would like to receive those invites, please mail to newsletter@infosim.net. So, and finally, I have to say thank you for all of you joining us and enjoy the rest of your day. Goodbye.